Okay, so today I'm announcing a new project that I'm starting on called Validi-TEE. I did a bunch of research in the fall, and starting at the hackathon, I'm actually going to start coding on it. So it's an open source. It's an open source secure enclave system for Bitcoin Lightning. Again, it's a kind of a greenfield project. It's definitely a research project, but the goal is to, within a year, have something that will run the validating Lightning signer inside of the Enclave. So the idea is to run on open source, self-sovereign, which I'll talk about a little bit, secure hardware. There's a secure enclave operating system called OPT or OPT that's been around for about 10 years, and I'm going to use that as the basic platform and to build on top of. Also, of course, there's a Linux kernel involved as well. The initial focus will be on ARM v8A. The A series or Cortex-A processors are ARM processors that run, basically they can run Linux. They have the memory management to run Linux, as opposed to the ARM M series, which are more microcontroller focused. So you guys know what the validating Lightning signer is. So OPT has been an open source project since 2014. It's maintained by trustedfirmware.org. It's sponsored by, I don't know exactly, but it's basically sponsored by ARM, and Linaro does a lot of the work on it. It's a trusted OS, and I'll get to some architecture diagrams that runs, that's loaded by the secure boot firmware and runs in parallel to the Linux kernel. The idea is that even if your Linux kernel is compromised, the secure partition is still protected by the hardware of the system. There are libraries and drivers to call into the trusted execution environment from the Linux or the Android side, which we call the RE or the rich execution environment. Again, there's a trade-off between having a fully functional OS with a lot of attack surface and a secure OS that does a lot fewer things, and therefore has a smaller attack surface. We're going to, for this project, we're going to focus on ARM Cortex-A trust zone. It can run on other architectures like Intel and RISC-V, but it's the sweet spot, I think, right now is on ARM, and so that's where I want to focus for this year. I should also talk a little bit about Global Platform, which is an international standards body that produces various standards for secure hardware and software. So they produce standards for secure elements, and also for the trusted execution environment. And in this context, there's two APIs that we care about: the TEE internal core API and the TEE client API. And you'll see those when we get into some of the technical details. So Validi-TEE is my working name. I'm open to suggestions, but there's kind of an unwritten rule that all TEE projects must have some kind of pun on the word TEE. So Validi-TEE, we're going to create some trusted applications that run inside the TEE. I like to call them trusted applets, but that's not correct. But they're basically like drivers more than applications. Some client applications for Linux, specifically the validating Lightning signer, and then to make it easy for people to develop on this, to provide a reference distribution of Linux with the open source firmware. So the goals for the first year are to write a white paper, write a specification, do a lot of work on the threat model and the use cases, because validating Lightning signer is sort of the first use case. But even validating Lightning signer has different use cases and configurations. Are you running it enterprise mode? Are you running it on low-end hardware? And that The opt-TEE based solution will be good for some use cases and maybe not quite so good for others. And then we're going to produce a developer's kit that will run on QEMU, and one of the major goals for the first year is to pick a hardware reference platform. So if anybody has any ideas or knowledge about that, I would love to talk to you. For the hardware reference goals, I want it to be ARM v8A, Trust Zone A. I want there to be no blobs involved in the boot process. It needs to be available without an NDA, because a lot of the secure hardware, when you get into the details, you need to sign an NDA with the manufacturer to get those details, and that's not great. We'd also like it to be widely available and reasonably priced, and ideally on the official supported list by opt-TEE, so that we don't have to mess around with drivers. We may not be able to get all 6 of these goals, but I think we can come pretty close. So some of the platforms that are under consideration, well, QEMU goes without saying, and that's my goal for the hackathon, is to get blind SecP 256K1 signing working with working inside of QEMU. One of the platforms that is supported is the Raspberry Pi 3, which is emphatically not secure, but it does implement the full Trust Zone hardware, and everybody's got one in a drawer somewhere. So it's kind of a tempting choice, but unfortunately, we really want to do something that's a little more secure. So we're probably not going to explicitly support that, but maybe someone will come along and configure it. Possibly that could be me. One of the platforms that does come closer to meeting our requirements is the Rock Pi 4, which is a Raspberry Pi clone, and it uses an RK3399 chip that has a full Trust Zone implementation. And I think you can get those for as little as like $50-$60. There's a bunch of development kits from different manufacturers that are available, several from NXP. One of the chips that I'm really interested in is this IMX8 ultra low power, which is a 64-bit embedded processor that's targeted for many applications, including smartwatches. So if we want something that runs opt-TEE and Validi that's in that sort of a form factor, that could be a good solution. Unfortunately, it's not currently on the supported list for opt-TEE, so there might be some driver development. I've reached out to NXP to get more information about it. So this is one of my goals, and I want to talk to anybody who has any knowledge or suggestions on this. I would love to talk to you, but it's something I'm going to be researching. So the architecture is there's well, I guess I'll just skip down to this diagram and explain sort of how the overall system works. So the left-hand side here is the normal world, or the Linux world, or the rich execution environment, and this side is the trusted OS. The ARM processor has various hardware modes of operation, with 0 being the I guess the least trusted. So EL0 here is where your Linux apps run. EL0 here is where trusted apps can run inside the T. This EL1, EL2 would be your Linux kernel, and then down here at the bottom is the trusted firmware. So for example, if you're running validating Lightning Signer here, and you want to sign a transaction, you use the T client API, which is standardized by global platform, to basically send messages down through the kernel, through the firmware, and over to the trusted environment. This is where the keys will be stored.
Airplane. If that gets too low, then you're going to have a problem. It turns out with the VLS tuning for embedded devices, the heap, the amount of available RAM, is the big challenge. So that number is very important, and we watch it all the time when I'm working on it. The next lines here, and then on the bottom are the received and the offered HTLCs. And the number on the left is the count. So right now there's 5 offered HTLCs, and they represent this many Satoshis in total. And that will go up and down as we send and receive things. There are no received HTLCs at the moment. The middle line is channels. And so right now it says there are 10 channels, and there's one which is being swept. So it's closed, but we haven't forgotten about it yet because we still need to sign sweeping transactions and the like. VLS will age the channel information until there's no possibility of it ever being needed again, and then it will be forgotten forever. Core Lightning has a very similar strategy there. Now the fun part, down here, these are the track displays. So each of these displays represents signing operations on behalf of a channel. So let's talk about this. It's jumping around. This angle bar right here means sign a remote commitment. The close angle bar is when the remote side gives you their revocation. And so that is the open angle bar and the close angle bar represent a complete update of your peer in terms of you sent them a new commitment and they sent back, okay, I've revoked my old one. Similarly, the squiggly braces are when the remote peer sends you a new commitment, and then the closed squiggly brace is when you revoke your update. So you're looking at pairs of those, and they can be interwoven and so on and so forth. Those represent the updates of the commitment. The up arrows, the hat, if you will, is pre-signing a justice transaction, possibly for storage in a watchtower. So I think of those as, send it up to the watchtower. So without further ado, what I'm going to try to do, so what you see over here are 3 different nodes. So there's 2 on the table here, and 1 is at home in California. And the one you're seeing here is in the middle. It's this node here. So I already generated an offer down here, and up here I'm about to execute fetching an invoice from that offer. Usually this takes about a second, but today, there we go, 10 seconds. Okay, and then I'm going to do a pay. So I'm going to go back to the, and paste this payment here. Okay. Now what we should see in the routing node, so this is the node in the middle, is eventually we should see a received amount, and then we should see the offered amount go up by a similar amount. I'm not sure why I may be having technical difficulties here. The arrow B that you saw go by was a heartbeat, by the way. The equal signs are checking pub keys. Yeah, I'm having my demo fail here, I'm afraid. Oh wait, here we go. That could be, yeah, there it is. The 100 Satoshis, 100,000 Satoshis is offered, received, and then we should see that go up. I was going to subtitle the talk, Tempting Fate. Oh, there we go. Yep. And so the H is signing an HTLC transaction. There, that went up. Now we're going to wait for it to close. That went down. That means it was accepted. And now this should go down. This is a routing node. Yep. In a different version of the talk, I did sending and receiving and all these different things, but routing is kind of the fun thing. Although, to be honest, for a consumer device, it's probably not important. You're probably not going to do a routing. It completed. By the way, you'll notice that The sender of the money thinks it got sent before the routing node is completely done with it, but it is committed, if you know what I mean. He's about to clear it. Yeah. Oh, there we go. It finished up. So, yes, but there's a lot of activity going on. So I'm running CLBOSS as well on here. It's balancing things. And the node also has some amount of traffic, even if CLBOSS is not running. It's updating commitments based on the fee market changing. So if the fee market goes up and down, then it will scan through all the channels and update, the commitments. I think that's kind of, I'm going to call it good enough. And so thank you very much for checking it out. And any questions, if you want to look at it up close, please come over and we'll kick the tires.